All right, so here we have 6.1 notes, which 6.1 is going to be to simplify monomials. So our goal today is to simplify monomials. And so mono means one, so this is just a one-term polynomial, which you'll see in a little bit. You'll see once we do examples. The vocab here, you'll hear it over and over, but it will become a little bit more easy to understand once we actually get into it. So to simplify monomials and to add, subtract, and multiply polynomials. So polynomials have many terms, not just one. A polynomial is an expression consisting of many terms. So we're going to go through the rules, and then I'm going to go through the examples, and I'll actually show you how you can use the rule, or you can expand it out and use what you already know in order to find it. So the first rule is if we take two numbers that have the same base, so the base is x, this has an exponent of m, this has an exponent of n, what we would do here is we would add those exponents. So we would have our base is going to be x, and then we would have m plus n would be your new exponent. So looking at this rule, you would still have a base of y, but your exponent is going to be 3 plus 4 added together, which is 7. Now I'm going to show you the reason why on a sticky note. So if you want to write this down, you are more than welcome to. It doesn't have to be in your notes. But y to the third power is written as y 3 times. Y times y times y. Y to the fourth power is y multiplied by itself 4 times. So what you end up with here, technically, you're multiplying in between all of these. So you have y to the 7th, because there's a total of 7 y's there. That's why you're adding them together. Okay, so this is how, when I say you can expand it out, this is what I mean by that. Instead of writing y to the third, we're going to write y times y times y. That's expanding it out. And then you can see what rule, or how you would apply that rule. On this one, if you want your answer to be left on the top of the fraction, then what you're going to do is you're going to take the exponents and you're going to subtract them. So we'd have x to the power of m minus n. Technically, this is over 1. You do not have to write it over 1, though, because dividing by 1 doesn't change the value. If you want your answer on the bottom of a fraction, then you would take n minus m. So notice these are the exact same fraction, but depending on if you want your answer on top or bottom will depend on which number comes first. So for example, b to the 7th over b to the 3rd. If we're going to write our answer on top, this would be b to the 7 minus 3, which is b to the 4th. This would still be over 1. You don't necessarily have to put it over 1, though. You could just leave it b to the 4th power. Now, now we left it on, we wanted it on top because you put it wherever there were more b's, and I'll show you again in the expanded version in a minute. But on this one, we would actually want our answer in the bottom. So we're going to put b's in the bottom. And again, the 7 would then come first, 7 minus 3, which is still 4, but it would then be on the bottom because more of them were in the bottom. So on this one, if we looked at the expanded version, for the one on the left, you have b 7 times on top and 3 times on the bottom. What happens is b over b is the value of 1, so those would cancel out or become 1. The next one would cancel out, and a third one would cancel out. We're left with b to the 4th in the numerator. On this one, though, it was the opposite. We had 3 b's on top and 7 on the bottom. 3 would cancel. Technically, you have this as a 1 times b times b times b, which is why that placeholder still needs to be there. So you'd have 1 over b to the 4th, which is what we had on that second one. So again, expanding it out will help you understand. You do not have to expand it out. Some students of mine have chose to expand it out every single time. We're not allowed to have negative exponents. So what happens if you have a negative exponent? This is the same thing as 1 over x to the power of m. If it was a negative exponent in a numerator, it just becomes part of the denominator with a positive exponent. If it was part of the denominator, it's going to become part of the numerator as a positive exponent. Okay, now this example is a little bit tricky because technically you have 2 times x to the negative 7th power. Okay, so we're going to have 2 times 1 over x to the 7th power. That negative 7 would tell you that that x to the 7th is part of the denominator instead. Now, typically what we'll do here is we write it as one fraction. So we'll leave the 2 on top. 2 over x to the 7th power is how I would write it. There's not really a good way to expand that out, but some people in class today brought up the this one up here. And if you would have looked at this b to the 7th over b to the 3, and you wanted to write your answer in the bottom, you would do 3 minus 7, which is negative 4. But that's the same thing as if we moved it to the top and made it positive, so b to the 4th, which is what we got. Okay, so this is using all of these rules. It doesn't matter the order you necessarily apply the rules in, as long as when we get down to the bottom where it says simplifying monomials, there's 4 key points. As long as you meet those 4 key points, you will be fine. The power of a power, if we have x to the m raised to the n power, what we're going to do is we're going to multiply m times n. So in this case, you're going to multiply 3 times 4. So you have z to the 12th power. Now, the way that you would expand that out is you have z to the 3rd 4 times. But then you could expand that out even more and write this as z, 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 which is z to the 12th. You have 12 z's there. It's just not very fun to count them when you get that many. So that's why it's beneficial if we know our rules. If you have a product in those parentheses, the product is the same as this one here. It's just that that n gets multiplied to not only one exponent, but both exponents in there. So in this case, it would be p. So p gets multiplied to both the m and the n on the inside. X to the m times p times y to the n times p. So in this case, there is an exponent on 3. 3 is the same thing as writing 3 to the 1st power. So make sure that you don't think that that 3 is linked with the x. The 3 is its own base. So it has an exponent of 1. So this has an exponent of 1, an exponent of 2, and an exponent of 3. They're all being raised to the 4th power. So we're going to multiply all those exponents by 4. We have 3 to the 4th power times x to the 2 times 4 is 8, 8th power. Y to the 3 times 4 is 12th power. The only thing in addition we can do here is since 3 is not a variable, we can evaluate what is 3 to the 4th power. So let me show you on the calculator where this button is. 3 to the 4th power, it's the caret button, so it looks like this. So if I type in 3 to the power of 4, it tells me that that answer is 81. So this is actually 81 x to the 8th, y to the 12th. The same rule applies with the quotient property. If you're taking something over something all raised to the p, then you're just multiplying both exponents by p. So we have x to the mp over y to the n times p. So in this case, the a doesn't have an exponent, so that exponent is an invisible 1. So we're going to take 1 times negative 5, so a to the negative 5th power over 3 times negative 5 is b to the negative 15th power. Now, these have different bases, so that's okay that it's written like that. But one thing that's not okay is we're not allowed to have negative exponents. So this a to the negative 5th is going to become part of the denominator, and that 5 is going to become a positive. So a to the 5th will be on the bottom. B to the negative 15th is going to move up top, and it's going to become positive. So that would be your final answer right there, b to the 15th over a to the 5th. Now, if someone asks, well, can you do something with the 15 and the 5? You cannot, because B and A are separate bases. They're different bases. If they were both A, yes, you would be able to apply the quotient of powers. Like up here, notice that the bases were both X. Here you have different bases. One's a B and one's an A, so you can't do anything with those. Anything raised to the power of 0 is equal to 1. Okay? If you're ever not sure, take anything to the power of 0. 5 to the power of 0 is 1. 10 to the power of 0 is 1. Anything to the power of 0 is 1. And if you can't remember, type it in a calculator. Okay? Now, this one, there's nothing you have to do here because this whole thing, it doesn't matter what's on the inside. It's being taken to the power of 0. So overall, our answer is just 1. We do have 4 rules to kind of live by when we are simplifying monomials. And the first one is that we cannot have powers to powers. Which mean you don't want any parentheses. Okay, so make sure to get rid of any parentheses. So if we have a parenthesis and a power on the outside, you want to make sure that you evaluate that to everything on the inside. The next one is that each base appears only once. Sometimes a base will disappear, and that's completely fine, but you don't want to have an X on the top of your fraction and an X on the bottom of your fraction. You want to move them to the same, either the top or the bottom. You want to combine them somehow so that X only shows up once in your problem. The next one is that all fractions have to be reduced. Okay, meaning if I have 12 over 4, I make sure I reduce that, both 12 and 4. 4 goes into them, so 12 divided by 4 is 3. And 4 divided by 4 is 1, so that becomes just 3. A common mistake I see here is that all of a sudden, since we were subtracting when they were exponents, people try to do 12 minus 4 and tell me that 12 over 4 is the same thing as 8. It does not work like that with fractions. When you are dealing with fractions, go back to what you learned back in 6th, 7th, 8th grade when you first got introduced to fractions, maybe 5th grade even. Use your basic rules about fractions that you know. Don't try to use anything new with those. Okay. The next thing is you cannot have any negative exponents. So no negative exponents. And we did an example like that here where we had a negative 5 and it made both of our exponents negative. So we moved them to make them positive. So no negative exponents. Also, another thing here is that if you have oh, I know. Negative 3 over 4. This cannot become, you can't like move a negative 3. That is just negative 3/4, the end. Okay, there's no way you can move a negative 3 to the denominator and all of a sudden it becomes positive. Okay, a negative number is a negative number unless it's in an exponent. Okay, if I had 1 to the negative 2nd power, that is, well, that was not a good example because 1 to any power is 1. If I had 2 to the negative 2nd power, that's 1 over 2 squared, which is 1/4. Okay, and you could even type that into your calculator. If you typed in 2 to the negative 2nd power, you'll see that it's a quarter, 0.25, math, fraction, it's 1/4, okay? They're equivalent, you're not changing the value of it that way. All right, so we have 4 examples here. I'm gonna use the rules and then I'll also show you how you could use expansion to figure it out, so if you expanded these. This is simplifying monomials, meaning these are all one-term polynomials, meaning there's no adding or subtracting involved, it's all going to be multiplying or dividing. So, since this is all multiplication, you can remove parentheses. You could also rearrange it. So what I like to do is write this as 2 times negative 7 times x to the negative 3 times x to the 5th times y to the 3rd times y to the negative 6. All I did was I put 2x to negative 7, the x's by each other and the y's by each other. Because 2 times negative 7 is negative 14. x to the negative third times x to the fifth, I can add those numbers together, negative 3 and 5, and get x squared. And then here, my y is being multiplied. 3 and negative 6 is negative 3. Now double check your rules. I don't have any parentheses, so I'm good there. Each base appears once. I have a base of 14, a base of x, a base of y. They all appear once. I'm good there. I don't have any fractions that must be reduced. This last one, no negative exponents. I have a negative exponent, so I'm going to have to do something to make it not negative. So what I'm going to do is negative 14x squared, I'm going to leave on top. I'm going to move y to the third in the denominator so that it becomes a positive exponent. This would be your final answer. Okay, that negative 14 is okay. You can have a negative number, just not a negative exponent. Okay. Number 2. The first thing I'm going to look at is the 15 over negative 3. That is a fraction that can be reduced. So 15 over negative 3 is negative 5 over 1, or just leave the negative 5 on top. Okay. The c's, there's more of them on top, so I'm going to leave the c on top. And 5 minus 2 is 3. The d's, there's more of those on the bottom, so I'm going to leave it on the bottom. And 7 minus 3 is 4. Okay. Now, the reason why I was looking to where there's more of them and know that that's where my answer is going to reside is because I could write this all out. And then what I can do is I can say, okay, 15 over negative 3, that reduces to negative 5. It doesn't matter if the negative's on top or bottom, as long as there's just one negative sign. C's will cancel, but since there's more on top, that's where they're going to be left. 3D's and 3D's, there's more on the bottom, they're going to be on the bottom. And then you would rewrite this, negative 5C to the third over D to the fourth, which is exactly what I got. So you can always expand it out if that helps you. You're more than welcome to do that. The only time it's going to be tricky to expand it out is if you have a negative exponent. So you're going to want to move it first and then expand it out. This one here, the a has an exponent of 1 and 4 has an exponent of 1. So this becomes a to the negative third over 4 to the negative third. Now we can't have negative exponents, so they're just going to trade spots. 4 to the third will become on top. A to the third will go on the bottom. And the last thing that I can do is I can actually evaluate what is 4 to the third power. And in your calculator, you could type it in. And it's 64. Next one we have is number 4. Negative 2 has an exponent of 1, and you remember you'll want to think of that in parentheses because the negative 2 is the number that the fifth power is going to apply to. So we're going to have negative 2 to the fifth power, x to the third to the fifth would be x to the 15th because you're multiplying here. Y squared raised to the fifth power would be y to the 10th. Again, you're multiplying there. The only additional thing we can do here is take negative 2 to the fifth power. Make sure that you put your number in parentheses because if negative 2 was being raised to an even power, it actually comes out as positive. So if you raise a negative number to an odd power, it's going to be negative versus the even power is positive. You don't have to remember that. As long as you know to put parentheses, you'll get the right answer. Okay, so it's important you use parentheses correctly. Negative 2 to the fifth power was negative 32, x to the 15th, y to the 10th. Now that's something you could have written out 5 times. If you write out negative 2 5 times, you could have also written it like this, negative 2 times, and then did that 5 times. And you'd also get negative 32. So that's another way you can write it if you're not sure. Or type it in your calculator. Okay, that's everything about monomials. If you have any questions about the monomials part, let me know. But I would take a break from doing your notes right now. I would pause the video, and I would move on and work on numbers 1 through 9 on your assignment. So 1 through 9 here, I would get these first 9 problems done. And if you have questions, then pause from there and make sure you get your questions answered. Okay, so hopefully you took a break from taking notes and you have done part of that homework assignment, that 1 through 9, and you've completed that. The next couple things we're going to talk about is how to decide what the degree of a polynomial is and whether something is or is not a polynomial. Then we'll add and subtract polynomials and multiply polynomials as well. So the degree of the polynomial is the degree of the monomial with the highest or greatest degree. Okay, so we first have to figure out how to look at each term and decide what the degree is. Now, I showed in class, when you write 75 degrees, like degrees outside, you circle this little spot right here. That's a degree symbol. So you kind of look in that same area to figure out what the degree is on a monomial. So this degree is actually 2 because the exponent is 2 on the variable. You're looking at what would be in the degree spot of the variable. Or you're looking at how many variables are there. Right there we have xx. So technically there are 2 x's there, so it's 2. Here you have x to the 5th, so it would be xxx. So that degree is 5. This has no x's, so it's actually 0. Okay? So the degree of this polynomial would have to be 5 because it's the highest number there. This is a 3-term polynomial, is a polynomial. Remember, to make a term, it's adding or subtracting in between. Monomial. So negative 4x squared is a monomial, plus this is a monomial, minus this is a monomial. It's a single term. Okay, so you're adding 3 terms together there. So there's 3 terms. When you're asked to simplify something, it is important that you put things in standard form. Standard form says that you order your terms in the order from highest degree to lowest. So if I wanted to write this in standard form, if I was asked to simplify something, I would not put this as my answer because I would lose points. I would rearrange it and write 6x to the 5th minus 4x squared minus 4. That would be my final answer because I rearranged it to be the degree of 5, the degree of 2, and the degree of 0. Moving on to number 2, this is not a polynomial because you're not allowed to have variables underneath radicals. Okay, a radical is a square root sign. So this one is not a polynomial. Cannot have a variable under a radical sign. Okay, so you don't have to find the degree of that because it's not a polynomial. This one here, this is a polynomial, but you're going to find the degree a little bit different. This first term has xx, y. Okay, there's actually 7 variables here. There's 2 x's and 5 y's. So because of that, your degree is actually 7 because that's how many variables are there. Your degree of this one is 6. This is already in standard form because the highest degree was first and then the 6th. Make sure you know how to find the degree if you're given multiple variables like that, because it's not always just the number that shows up there. So the degree of the polynomial is 7. This one, because it's a polynomial, we also can state that it has 2 terms. Eventually, we're going to have to know how many terms are in a polynomial. So that one has 2 terms. The degree of that one is 7. All right, so for that last one, this one is not going to be a polynomial. You cannot have negative powers because you would have variables in the denominator. So you cannot have negative exponents on variables or variables in the denominator, which is exactly what that means. That means 1 over x squared. So that means you have a variable in the denominator, which is not allowed. So that's not a polynomial. All right, adding and subtracting polynomials. Now this goes back. You guys know how to do this. If you're adding, all you need to do is remove the parentheses. So I'm going to rewrite this without parentheses. Negative x squared minus 3x plus 4 plus x squared plus 2x plus 5. If you really want to, when you're adding, order doesn't matter. We could rearrange the order and write negative x squared plus x squared minus 3x plus 2x plus 4 plus 5. Now, you don't have to rewrite that. That's not necessary. The reason I did it is because I wanted you to see I have multiple terms that have x squared. I have multiple terms with just x. And I have multiple terms that don't have a variable. Because all you're doing here is something that you guys are experts at, combining like terms. Negative x squared and x squared actually cancel. Those become 0. Negative 3x plus 2x is negative x. 4 and 5 make 9, so negative x plus 9. The only thing in addition that you want to remember here is that order matters in your final answer. This has a degree of an invisible 1. This has a degree of 0. So we have to make sure that when we write our answer, it's in the order from highest to lowest. So our final answer has to be written negative x plus 9 because that's in the order from the highest degree to the lowest. When we subtract, we are not allowed to just quite drop the parentheses because the subtraction sign has to be distributed to all 3 of these terms. So we have negative x squared minus 3x plus 4 minus x squared plus 2x minus 5. All the terms in that second set of parentheses, because it was subtracted, have to change. So the x squared became negative, the 2x is positive, and that 5 is now negative. Now again, we can combine like terms. So we have a negative x squared and another negative x squared, a negative 3x and a positive 2x. We have 4 and a negative 5. So combine like terms. If you don't want to have to rearrange it in the end, find the term that has the highest degree. The highest degree is the x squared term. Negative x squared and negative x squared is negative 2x squared. Negative 3x and 2x is negative x. And the lowest degree is the 4 minus 5, which is minus 1. And then that's already in order, and that would be your final answer. Multiplying polynomials. So now we've done adding and subtracting. Oh, I forgot to write in here. This, all you're doing here is combining, so combine like terms. That's the big thing to remember here. Okay. Combine like terms. Multiplying polynomials. Now you guys know how to do this also. This is just distributing. So if we are multiplying 3x by, which is a monomial times a polynomial, you're just going to take that 3x and multiply by all those terms. What you are then doing is you're taking 3x times 4x squared plus 3x times 7x plus 3x times negative 2. That's all you're doing there, is you're just multiplying 3x by each of these terms. Okay, well, if you look at this, this is exactly what we've practiced already with simplifying a monomial. 3 times 4 is 12. X times x to x squared is x to the third. X times x times x is x to the third. Plus, let's look at that middle term. 3x times 7x, so 3 times 7 is 21. X times x is x squared. This last one, 3x times negative 2, would just be minus 6x. Now double check. The degree here is 3, the degree here is 2, the degree here is 1. You're already in order, and that was your final answer. Now there's two different ways you can go about multiplying this is a binomial times a trinomial. Bi meaning 2, tri meaning 3. So 2 term times a 3 term. It doesn't matter the order that you multiply them in. So I typically will distribute the x to all 3 over here and the 4 to all 3. Because if you try to distribute x squared to these two, sometimes you lose track on your arcs if you're making the arcs like we did over here. So what I usually do is I distribute the binomial to the trinomial. So if I distribute x to x squared, I get x to the third. X to 4x, I'm going to get 4x squared. If I distribute x to 16, I'm going to get 16x. And I'll color coordinate this for you. If I distribute the -4 to all 3 terms, and I've heard people call this the seashell method because it kind of looks like a seashell once you have all those arcs in there. So -4 times x squared is -4x squared. -4 times 4x is going to be -16x. -4 times 16 is -64. Okay, so then what we're going to do is we have to combine like terms. So the x to the third is the highest degree, so I'm going to write that one first. Then I'm going to go to the second degree. I have 4x squared minus 4x squared. Those actually go away. Those become 0. Then I go to my x term. And 16x minus 16x, those also go away. And minus 64 is the last one there. And that is in standard form because I went from highest degree to lowest degree. And that's how you do number 2. Now the other way to do number 2, I'll show you on number 3. So you can use the seashell method or you can use the box method. Once you get to number 4, I would recommend definitely use the box method. For number 3 though, I'm going to break it down to an easier problem. If I do 2 times 5 times 6, in order to multiply these, I multiply the first 2 and I get 10 times 6 still. And then I say 10 times 6 is 60. The same idea goes when you're working with 3 polynomials. I'm going to take the first 2, I'm going to multiply them. Multiplying those first 2, it's just FOIL, or distributing. So your first, and then your outside. So I have x times x, which is x squared plus 7x. And then -4 has to distribute to both. So first, outside, inside, last, if you know FOIL. Minus 4x minus 28. And all of that are those first 2 multiplied together. But I still have to multiply the x minus 2 into it. But we'll get there, I promise. We need to simplify this though, because these do have some like terms that we need to combine. So I have x squared plus 3x minus 28, and I still have that x minus 2. Now you could use the seashell method again, okay, where you distribute the x to all 3 terms, the -2 to all 3 terms. Or you can use the box method. So this box method, we have a 2-term polynomial times a 3-term polynomial. So we're going to draw a box that's a 2 by 3. And on the side that only has 2, I'm going to write x minus 2. And on the top where there's 3 terms, I'm going to write x squared, 3x, and -28. And then what I'm going to do is I can distribute easily x to all 3 terms and -2 to all 3 terms. X times x squared is xx, which is x to the third. 3x times x is 3xx, 3x squared. -28 times x is just -28x. -2 times x squared, -2x squared. -2 times 3x, -2 times 3 is -6x. -2 times -28 is going to be a positive 56. Then all you have to do is combine like terms. So x to the third is the highest degree. Then we have some x squared terms, which is the next highest degree. Some x terms, that'll be the third highest degree. Let me find a third color here, or fourth color. The 56 would be your last one. So when we write this, our final answer is going to be x to the third has to come first. 3x squared and negative 2x squared is plus x squared. Negative 6x and negative 28x is going to be a negative 34x plus 56. And that would be your answer. Now, when you get to the 3 by 3 polynomials, a trinomial times a trinomial, I would definitely recommend the box method. You can distribute, you're going to have such a long chain that it gets really messy. And you're going to have so many arcs and stuff that it also gets messy. So this is a 3 term times a 3 term, so I would just draw a 3 by 3 box. Across the top or the side. It doesn't matter if the first one's on the top or the side. You could decide. It does not matter. So x squared, 4x, and negative 3 are my 3 terms. Down the side, I'm going to write 2x squared minus 4x and a positive 3. And then I just start multiplying. So 2x squared times x squared, 2xx would be 2x to the 4th. Again, you can write these out, expand them if you need to. 2 times 4 is 8. X squared times x is x to the 3rd. Negative 3 times 2 is negative 6, and then I still have that x squared there. And I'm just going to keep going. Negative 4x times x squared is x to the 3rd. Negative 4 times 4 is negative 16. X times x is x squared. Negative 3 and negative 4 is a positive 12, and I still have that x. 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times negative 3 is negative 9. Now, the nice thing about the box method is if you write your terms across the top and the terms across down the side in order from highest to lowest, then your like terms are on this nice diagonal. And they should be in order if you start in order. These ones were given to us in order, so it worked out nicely. So now we can see all of our like terms. So the 2x to the 4th is that's the highest degree. So that's going to go up front, and there's nothing to combine it with. Negative 4x to the 3rd and 8x to the 3rd is plus 4x to the 3rd. And then we have 3, negative 16, and negative 6, which would be minus 19x squared. 12 and 12 is 24 x's. And then the lonely minus 9. And it should already be in order from highest degree to lowest, so just double check. Degree 4, 3, 2, 1, 0, and you're good to go. That's it for notes. I did have a couple questions in class today, so I will go quickly over them. When you are dealing with something like number 17, where there's multiple variables, I would do this box method, okay? So if you set up your box, okay, a plus b along the side, so a plus b, a to the 3rd minus 3ab minus b squared. When you have something like this, negative 3ab times b, it'd be the same thing as writing out negative 3ab times b. And then from there, you're just going to simplify that monomial just like we did in number 1 through 9 on the assignment. So this becomes negative 3ab squared. Now, in order for that to combine with another term, it has to combine with another ab squared. A squared b and ab squared, those are not going to be the same terms. Okay, they're not like terms. So we could not combine them. They have to have the matching ab with an exponent of 2 on b. Okay, so that's just something I wanted to point out. So those would not be like terms. If this was like a 4, we could not combine those in any way, shape, or form. Okay, it would have to be AB squared and AB squared in order to be like terms. So if you have more questions on that, let me know.